Hello everyone. In the last class, we discussed merge sort using divide and conquer approach. Now, today we will discuss the quick sort using divide and conquer. So, as the algorithm are when we are using this technique, divide and conquer. So, the first thing we will divide the array elements based on a reference point. One reference we will take. In case of merge sort, we have taken midpoint. We have calculated midpoint and we separated the all the elements in the array. Similarly, in quick sort, we are going to use one reference point called pivot. It may be any index in the array, but generally we will take the first index is the pivot element, pivot index. Let us consider an array. Right now, 4, 6, 1, 7, 3, 2, 5. So these are the elements present in the array. Now we will apply the quicksort to sort these elements. Right now, what we will do? The first thing is anyway the time complexity will be big O of n log n, because when we are having a array, we are performing the loop operation. This is for looping, and log n, this is for a recursive operation. When you are performing the recursive, when in merge sort also we have conquering. When we want to do the conquer operation, that is recursive operation, the time complexity will be log n. And when we are having the set of elements, every element when we are comparing, so we require one loop. So the total time complexity of this divide and conquer based sorting, time complexity will be n log n. And space complexity will be here O of 1, because in merge sort additionally we used one more temporary vector, but here we are not using any additional thing. So you can say space complexity will be O of 1. Now we will go to the how we will perform the quicksort. Now we will see the first thing, whatever we got the array. First we have to mark the pivot point. So this is the pivot index. Now, let us take indexing 0, 1, 2, 3, 4, 5, and 6. So, total 7 elements are there. Now, how this algorithm will work? First, we will mark the pivot index, and next one, we will compare all the values, all the individual values with the pivot index value of the pivot index. Now, what we have done in the merge sort, so now what we have done, we calculated the mid value, and recursively we are calling the left side and right side. No, same procedure here also. We will have one to compare that, we will use the I. Now, what we will do, if 6 is greater than 4 or less than 4. So now what I will do here, I is greater than pivot index or less than pivot index. If it is greater than, no need to do anything. If it is greater than, I value is greater than pivot, you have to increment the I. I should be incremented. What we will do? 6 is greater than 4. So now what I will do here, I will be incremented. So now your I will be here. Now, if I is here, now again I am going to compare with the pivot index. So now I greater than pivot index. So this is not satisfying because I value is less than the pivot index. So we have to perform one operation, that is swapping of 1 and 6 we have to do. To perform this swapping of 1 and 6, one more index we are going to take, that we will take it as swap index. Just for our convenience, I have taken as swap index. Now in this swap index, I will take it as first initially pivot index and swap index in the same place. So now what I will do initially, swap index is equals to pivot index. And what about I? I is nothing but pivot index plus 1. Pivot index plus 1. Initially, this is the initial when we are considering what is swap index, what is the I location. Now, first what we have done, we have considered 6 is my I. So I will mark this one is high. So now this is your I, because I will be pivot index plus 1. First, what we will do, 6 I'm going to compare with 4. Is this a greater value or less value? 6 is greater. So your I is greater than pivot index, value of the pivot index value. I value of I is greater than pivot index value. Then I should increment. No, don't do any operation. You increment the I. So what will happen? Your new I will come here. So this we are going to increment it. New I will come here. Now, when I'm comparing I with the pivot index, so I is comparing with the pivot index. I value is less than that. I is less than the pivot index value, index value of I index. I index is 1 and pivot index is 4. So 1 is less than 4. When it is the I value is less than 4, what we have to do? We have to perform the swap with the previous high. What is the previous high? 6. So to perform that, before performing the swap operation, what I will do? Swap, I'm going to increment by plus 1. Swap plus plus. So now when you found any I value less than the pivot index, you increment the swap by 1. Any value, if you found I value less than the pivot index, increment the swap index by plus 1. So now your new swap will be at 6. So this is your swap. Is it right now? Now what we have to do? We have to, once you incremented the swap, we have to interchange this. We have to interchange or we can say swap the I and swap index. If you interchange the I and swap index, how the array looks like? 4617325. 4617325. This is what now. Now what I will do? So these two I'm going to interchange. I'm going to perform the swap operation. So 1 will come here, 6 will be there. So 1 will come here, 6 will be there. Now, what we will do? Your 4 is your pivot index. Indexing, it is not the value. And here is your swap. And this is your I. So once we have interchanged that, so this is swap and I only. Now what we are going to do this 6 we have already compared. So now I am going to perform I plus plus. So your new I will be 7. I am going to compare with 7. Now 7 is greater than 4. 7 is greater than 4. No operation. No need to perform any operation. Leave it as it is. Now increment the I plus plus once again. Once you perform the I plus plus, again I will come here. I will come here. Your new I value will be 3. Now 3 I'm going to compare with 4. When I compared with 4, 3 greater than 4 is not correct. It is not correct. So we have to perform the operation. What we have to perform? Swap index increment by 1. Swap index increment by 1. With the new swap and I interchange the values, interchange the, or we can say swap the values. We are not changing the indexing pointer. We are changing only the values. What we have to do? Swap, we are going to increment by 1. So what does it mean? 4, 1, 6, 7, 3, 2, 5. This is anyway pivot P. And swap, I am increment by 1. That is, here is the S. And I is same. This 3 is showing. Now when I observed 3 is less than 4, what we have to do? First we increment the swap so that swap reach to the 6. Now you interchange the values. So this value interchange. So this value will be 3, this value will be 6. Now again, once one operation if you perform, increment the I plus plus. Once you increment the I, so 2 less than 4. So our new array will be 4, 1, 3, 7, 6, 2, 5. Right now, this is your P. S is showing at here. I is showing here at 2. Now, what I'm doing, 2 is comparing with 4. When 2 is comparing with 4, is it 2 greater than 4? No, it is anyway 4 is greater than 2. So when you have less than a value less than the pivot index value, then you have to increment the swap by 1. Swap index by 1. Where is the swap index? Here is the swap index. I will increase the swap index by 1. So this is your new swap index. And I'm going to perform swap operation between new swap and I. So this will be 7 and this will be 2. This will be 7 and this will be 2. Now, what is the new array we got? 4, 1, 3, 2, 6, 7, 5. Now the last, anyway, here, this is your P and here is your S, swap index and I index. Now this, because we completed one operation, now I will increment the I to here. 5 is greater than 4. 5 is greater than 4. So no operation, no need to perform any operation. Now, once you completed I value to the end index, once it reached to the end index, if there is no element to compare with the pivot index, then whatever the pivot index value, you have to interchange with the swap index value. Interchange these two. Along with that pivot also you have to interchange. Index also you have to interchange. So what is the new array looks like? Here I'm going to write 2, 1, 3, 4, 6, 7, 5. Now this is your pivot right now. Anyway, this is a swap is a temporary index. I is a temporary value. So you can ignore that. So now 4 is our pivot value. Now it is in the mid of the array and the left side is less than 4 and right side is greater than 4. Now again we are divided a big array into two portions. One is left, another one is right. As we have done in the midpoint in the merge sort also, same what we have done based on the midpoint, we divided left and right. And again, in the left, we have to perform the same operation. So this is your new pivot, compare, interchange. So similarly, you have to perform like you can say recursively. You have to perform the operation. That's why this is the to perform the quicksort. We are using divide and conquer approach because recursive algorithm we are performing. Now further, your time complexity and your space complexity. I hope you understand. Now we will move on to the program. So already we completed the merge sort. Now we are going to look for the quick sort. Now, when we are writing the code, first thing you have to understand, we have to perform the swap operation. Is it right now? Now anyway, we will write hash include IO stream using namespace std int main. Right. Now first we are going to perform the swap. How to write the code for swap? One function we will write void swap in an array. So my in an array, if I want to perform the swap means I want one array which is an integer type int. I want first index and last index, or we can say int one more. We want two variables a and b. How you are going to swap a and b? First, a value or a I'm going to store in C, then B I'm going to store in A. Then what we will do? C value I'm going to store in B. So you can swap the A, B values, right? Similarly, same logic here also. First, I will take one temporary variable. So temp is equals to array of first index. That means A. Generally, we will take it as A, no. So A and array of second index I'm going to store in the first index. Array of first index is equals to array of second index. Once we have done this, array of second index I'm going to store from the temp. Second index is equals to temp. So this is a basic AB values swapping, swap the values between two variables. Same logic, no complexity in this. It is very simple. Now, when we come to the pivot, how we are going to write the pivot. Here we required three variables. One is I, another one is swap, another one is pivot index, and as well as end index also. Now I'll write int pivot function. I'm going to write here. In this, the first one, so int array. So same name, I'm keeping that ARR of, and int pivot index, comma int end index. Okay, once we have done this, next, initially what we discussed in the program, the swap index is same as pivot index. So now int swap index is same as pivot index. There is no change in that. But for I, what we discussed, I is nothing but pivot index plus 1. So now int I is equals to pivot index plus 1 to I value less than end index I plus plus. Now, so now we created pivot index, swap index, and I. Now we have to compare. Once we have the all the indexes, for every value of I, I'm going to compare with pivot index value. If array of I, if array of I less than array of pivot index, array of I less than pivot index. If this is the case, what we have to do? I value is less than pivot index. Array value is I value is less than pivot index means what we have to do? We have to increase, we have to perform the operation. What operation you have to perform? Swap index. I'm going to perform increment. We just think about what we discussed in the theory. Now I'm going to swap the two indexes, like two I and swap index. I'm going to perform that one operation. I'm going to perform in a array. I'm going to call array swap index, comma I. I'm going to perform the, I'm going to call the swap function. Anyway, we have written here. Same I will call, and I will mention I want to interchange I and swap index values. Now, once we have done this, if it is less than, we have to perform operation. If it is greater than, no need to perform any operation, right? So now what we will do here, and finally, once we reach to the end of the array, finally, we have to interchange. We have to interchange. Okay, 1 second. After the, once we have completed all the comparison, what we have to do? We have to interchange the pivot index with the swap index. Right, no. For that same, I will call the same function. I will call here, and I will in the swap index and pivot index. I'm going to pivot index, okay, comma swap index. I'm going to perform the again swapping the, and finally when it reach to the in the above problem 4 will reach to the middle left side if you see all the less values, right side if you see all the greater values will be there. Now that index you are going to write here, return swap index. So now why we require this swap index, because when we want to segregate left and right, when we want to call the recursively left and right, so we want this swap index. So that is why we will write this. Now we will write the main function. In the main function, so int some my array is equals to my array is equals to. So what are the values we have taken? 4 comma 6 comma 1 comma 7 comma 3 comma 2 comma 5. So total how many? 3 7 values we have taken. So 0 to 6 index. Okay. Now what is the size of the array? So int I want size of the array, because end index I want to calculate. No. So size of the array means size of my array divided by size of my array of indexing 0. So you will get the size of the array. Now I want to call the function, pivot function I want to call. So I will store the result in index. I mean, because when we are calling the pivot, it is an integer. The return type is integer. So now I will store the whatever the swap index I'm getting. I'm going to store in one variable. So int return index. So this is what I got from the uh, pivot function. So now what is the index I'm going to get? That I'm going to store, because I want to recursively call the left side and right side. No, that is what I want. Now what I will do here, int return index is equals to pivot of my array, comma 0, comma size minus 1. So this is the start index and end index. Now what we will do here, cout returned index is this. I'm going to paste here, return index. So inline. Now I want all values to be printed, right? So now what I will do here, for I will use one keyword called auto values in the my array, whatever the values in the my array, I want to print here. Cout value. So now I want the how the array looks like after the first iteration, or you can say first when we calculate the pivot index. Now we will run this program. Now if you observe, 4 is it in the center, and the left side are less than the 4, and the right side is greater than the 4. So now once if you observe our final, not final answer, when the pivot index will be in the middle. So this is the uh, array elements looks like. Now again what we have to do, again left side 213, again we have to perform the same approach. 675, again we have to perform the same thing. So for this, what we will do, recursive operation, recursively we will call. How to do that? Just a simple one more function we will create, that is quicksort. Here we are going to perform the quicksort. Here again we will call the array 3 times. One is for first time to make pivot in the center, and the second one is for left sorting and right sorting and final sorting. So now what we will do here, we will create one function. Here we will create one function, void quicksort. So int array. Now I want left index and right index. So int left index, because now it became two subarrays, right? Now int right index, left index and right index. Now whatever we got the return index, that we are going to use here. Now first we will have one array that I'm going to call I'm going to call the pivot for the first time. In that first time when I'm calling, I will store the array. I want to sort this with the left index and the right index. And the result I'm going to store in the pivot index. Result I'm going to store in the pivot index. Now, again, what we have to do? We have to sort the left subarray and right subarray. Now, again, we have to call this recursively. We will call this quicksort array left index. Now whatever you have calculated. For example, you have to sort 213 and 675. 213, if I want to sort, what is your starting index is 0, or we can say left index. What is your left side array end index is pivot -1, right? No. So now pivot index -1. This is for left. For right, from pivot index +1 to end index, or we can say right index. Same again, once again we will call. Uh, Pivot index +1, comma right index. So this one I'm going to call here +1, comma right index. Right now. Now, if, and finally, once it reaches to the final condition, that we are going to write here, if left index is greater than or equal to right index. If left index is greater than or equal to right index. So it is already sorted. So no need to do anything. You just return nothing. You just write that. Now, once we have completed the right side sorting, left side sorting, we'll go to the main function now. In the main function, what we will do? So anyway, into my array, we have written pivot function just for understanding how the first time the sorting will happen. Now I'm going to perform this one. I can make it as comment. Now we are going to call the function called quicksort. So now here we are going to call the function. So this one we are not call, just we will make it comment. Now what we will do? We will call the directly quicksort function. So quicksort of my array comma 0 comma size -1. So once you are calling this function, and anyway after sorting how the values looks like. So now we will run this code. You see here 1 2 3 4 5 6 7 3 4 5 my array of 0 my array. Now if you run the code, you will get 1 2 3 4 5 6 7. Now I will share this code with you. You can practice. Thank you.